All right, today we are talking about dividing rational numbers, and I have excellent news, and that is since multiplication and division are inverse operations, they follow the same rational number rules. So our rules for what we just learned with multiplication apply to what we are going to be learning with division, and we're going to look at a few examples that will hopefully prove that to you. First, we're finding missing values in the equations here listed. And we have these 5 equations listed. Notice how they're all very similar and they're all kind of working with the same pair of factors. 3 and 4 equals 12 in some manner. It's just one of those numbers is missing. So, with what we've learned the last couple of days about multiplication, remember if we have one factor that's negative, the other is positive, that gives us a negative product. So our missing value here, if we multiply negative 3 times 4, is negative 12. Now, if we look here at the next one, we've got still the same negative 3 factor. We're going to be multiplying by either positive or negative 4, and we have to get 12, a positive 12. Now, if we put 4 here and only one of our factors is negative, we get a negative product. So we need 2 negative factors, meaning that we need to multiply negative 3 by another negative number in order to get positive 12. For the next one, we want to keep our product positive. We have a positive factor, so we need another positive factor. So 3 times 4 equals 12. Then if we look at the next, a negative factor, this one is very similar to this example. We have one negative factor. We're going to need another negative factor if we want to get a positive product. So we need to multiply negative 3 times negative 4 in order to get positive 12. And then lastly, we need to turn our positive factor negative, so we need a negative factor to get that negative product. All right, this is what we learned the last couple of days. Hopefully, there's nothing too surprising there. Now what we're going to do is we're going to rewrite the unknown factor problems as division problems. So these are the exact same equations that we were just dealing with. Now we need to rewrite it with division. So remember with division, we can always divide the product by one of the factors to find the missing factor. So in this first one, if our answer was negative 12, if we take negative 12 divided by one of our factors, doesn't really matter which one because it's going to equal the other. So let's divide it by 4. Then we'll get our second factor of negative 3. Okay? If we continue that, if we do 12 divided by negative 3, we get our missing factor here, which we found up here to be negative 4. If we continue that, 12 divided by 3 equals 4. 12 divided by negative 4 is going to equal negative 3. And now negative 12 divided by 4 will equal negative 3. All right, so all I've done is I've just rearranged these equations above. I've divided the product by one of the factors to find the other factor. And that works with all multiplication and division problems. What we need to look at now is what pattern can be found here. So in this division problem, we had one negative and one positive, and we got a negative outcome. So let's look at that. Let's see if we can find other examples like that, where we have one negative number in our division problem, and we still get a negative outcome, negative quotient. That happened here as well, and it happens here as well. So that tells us that if one of our numbers in the division problem, doesn't matter if it's the dividend or the divisor. If either of those is negative, then our product will be negative. Of course, if we're dividing positive numbers, I'm sorry, I said product, then our quotient will be negative. If we're dividing positive numbers, our quotient's going to be positive. And the only one that we haven't seen here is what happens if we divide a negative number by another negative number. So let's pick, let's see here. Let's do that with this first one. So this first one was -3. No, actually that won't work. Yeah, well, we're just going to rearrange it. So we're going to take -12. We're going to divide by the other factor. So instead of dividing by 4 like we did here, we'll divide by -3. Okay, now we're dividing two negative numbers. Our dividend and our divisor are both negative, and we know it's going to equal the other factor of the problem from up here. So it's going to equal +4. When we divide two negative numbers, we get a positive quotient. Just like with multiplication, if we multiply two negative numbers, we get a positive product. So we're going to investigate that a little bit more. To clarify, let's look at the next set of questions. And it's just got a few statements for us to look at that kind of sums up what we just talked about here. So the first statement says, the sign of a positive number divided by a positive number is always, meaning the answer, the quotient here, is going to be positive or negative. If we divide a positive number by a positive number, well, of course, that's going to be positive. If we divide a positive number divided by a negative number, that goes back to some of those examples where we're dividing a positive number by a negative number. One of those values is negative, so our quotient, our answer, is going to be negative. Now they just reverse it, the sign of a negative number divided by a positive number, and that makes no difference here with this rule. We still just have one negative number, so we'll have a negative quotient. But if we have two negative numbers, we get a positive quotient. And that's it. Again, that's the same rules from multiplication. If one of our factors is negative, our answer is negative. If one of our numbers in our division problem is negative, our answer is negative. But if they're both negative, then it becomes positive. Let's look at the next one, which says Han and Claire walk towards each other at a constant rate. They meet up and then continue past each other in opposite directions. We will call the positions where they meet up 0 feet and the time when they meet up 0 seconds. Han's velocity is 4 feet per second. Claire's velocity is -5 feet per second. Where is each person 10 seconds before they meet up? I think this would be a great thing to draw out. So we'll draw their path. And remember, we have our positive end and our negative end, like on a number line. 0 here in the middle is that meeting point. And if you remember from the cars and the traffic cameras, if the velocity is positive, that car, that person is traveling towards the positive end. And if it's negative, they're traveling into the negative end. So the person with the positive velocity is Hans. His velocity is 4 feet per second. So Hans is going this way. This is Hans. And it's 4 feet per second. And Claire is -5 feet per second. So Claire is going this direction towards the negative side. Claire, let's see, -5 feet per second. Okay, so where is each person before they meet up? 10 seconds before they meet up. That's what we're answering here. Well, 10 seconds before they meet up for Hans, he's going to be here on the negative sign because he's 10 seconds away from meeting Claire. He's going to be on the negative sign, and we would get that by taking his velocity times -10 seconds. Now, we talked about this with the cars. -10 seconds was 10 seconds before the meeting point. So Han would take 4 times -10, and his position would be at negative 40 feet over here on the negative side. Claire, going the other direction, 10 seconds before this meeting point, going back 10 seconds, is going to be over here on the positive side. And that's because Claire is going to take her velocity of negative 5. She's going to multiply that by being 10 seconds before. That's still negative 10 seconds. And when we multiply two negatives, we get a positive 50 feet. Then the question asks, when is each person at the position negative 10 feet from the meeting place? So if we look at that, when is each person at the position negative 10 feet from the meeting place? So negative 10 feet, being over here on the negative side of the number line, is going to be for Hans before he reaches this meeting point. And then for Claire, it's going to be after the meeting point to get to negative 10 feet. So if we look at Claire, Claire is going to be traveling this way. This one might be a little bit easier to do first. She's going negative 5 feet per second. She's going in the negative direction. She's going to meet. Let's mark our position here. So we're trying to get to this point here. We're just picking a spot, and we're going to call it negative 10. So Claire will meet Hans. She's going to go one more second, which would be negative 5 feet. And in another second, she'll go another negative 5 feet to negative 10. So it will take Claire 2 seconds after meeting Hans. That's going to be positive 2 seconds. So Claire is positive 2 seconds. But Hans would be at this position before the meeting point. So we have to go to a negative time for Hans since it's going to be before he meets. Now, Hans is traveling slower. He's traveling 4 feet per second. So if we go from here, we go back a second. So a negative second, he'd be at negative 4 feet. He's 4 feet away from this meeting point. If we go another second, he's at 8 feet from the meeting point, negative 8 feet. And then we need another half of a second to get to negative 10. So Hans is going to be a negative time because it's before the meeting point, and it's going to be negative 2.5 seconds. All right, let's look at some more examples here. Taking it out of the word problem context will hopefully help a little bit. And we're going to look at some more equations here. And it wants to know, is the solution positive or negative? So we're just going to look at these. We've got 2 times something equals 3. Now, we don't even have to answer it. We just have to say if it's positive or negative. So I'm just following my rules here. These are all multiplication problems. They're going to follow the multiplication rule, which is if there's one negative factor, my answer is negative. My product is negative. If there's 2 negative factors, then my product is positive. So I've got a positive factor times another positive factor gives me a positive product. So this one here is positive. Next, I've got a negative 2, but I have a positive answer. How am I going to turn a negative factor into a positive answer, a positive product? I need another negative value there because multiplying 2 negative factors gives me a positive product. Looking here, positive factor, negative product. I need to turn this to a negative quantity. This has to be negative. And then finally, negative factor, negative product. I don't want to change this. This is going to have to be positive. Okay. Now, finally, we've got some more examples here. It says find the solution mentally, and I would like you to just take a second to do that. Use the rules that we just reviewed and talked about with multiplication. Go ahead and do that, find those values, and then check the answers in the notes to follow. Okay, now we're going to take a look at another word problem. It says a water well drilling rig has dug to a height of -60 feet after one full day of continuous use. Assuming the rig drilled at a constant rate, what was the height of the drill after 15 hours? First problem here. We have a drilling rate of -60 feet in a full day. And our question is asking us in 15 hours what the height of the drilling rig is. Now, of course, it's negative because this drilling rig is digging into the ground. It's drilling below the surface of the earth. So it's going 60 feet every full day. A full day is 24 hours. So I need to do some converting here. I could work in parts of a day, fractions of a day, because 15 hours is a fraction of a day. But I think to make it less complicated, what I'd rather know is what is the drilling rate for this drilling rig per hour. If it can go -60 feet in 24 hours, then I should be able to find the unit rate here and find out in 1 hour's time how many feet the drilling rig can drill. And that's what I'm going to do. So I could set up a proportion. This is going back again to proportional relationships because we're dealing with a constant speed here. And we want a practical speed. We don't want to know -60 feet in 24 hours. That's much less helpful. What we want to know is how many feet, which is a missing value right now. It would be in 15 hours, or, well, truly, we could find that for 1 hour and then find 15 hours. I think finding this unit rate first would be most helpful. So we just need to divide this ratio. We need to take -60 divided by 24. And when you do that, what you get is -2.5 feet. So every hour, this drilling rig is going -2.5 feet. The question asks for 15 hours, so we just need to make this 15 times greater. So multiply that by 15, and we'll get our answer, which is -37.5 feet. Remember, all these quantities are negative because we're going below the surface of the earth. Now, we can put this on the graph, and that would certainly be good information, but we know that in 15 hours, what we just calculated here, -37.5 feet. So we're going to have to kind of estimate here. Be someplace around there. We know that in 24 hours, it went -60 feet. Let's see, which would be about there. And it is a proportional relationship. So we can draw as straight a line as we possibly can to represent the rest of those values. We don't want to use this in calculating anything. We want to actually calculate to be precise. But this gives us an idea if we're kind of in the ballpark of where that drill would be after a certain number of hours. Because the next question says, if the rig has been running constantly and is currently at a height of -147.5 feet, for how long has the rig been running? Now that's almost -150 feet. And if we look at our proportional relationship, that's about 50 hours. So we need an answer that's close to that to know that we're in the right ballpark. But let's figure this out. So we could create a table to represent our proportional relationship where we're comparing hours and feet. We know our constant of proportionality because we found the unit rate right here. So the constant of proportionality is -2.5 feet. That's the speed of the drill, -2.5 feet every hour. And if we reverse this now, because we want to turn feet into hours, so this would have been labeled hours and feet. We were multiplying by the constant of proportionality this way. To reverse that, we'd use the inverse operation. We would divide. Let's take our number of feet, divide it by our constant of proportionality, and look at this. We're dividing a negative quantity by another negative quantity. That should give us a positive answer, a positive quotient, and that's a positive number of hours. It should be positive in this case. So we'll do that division and find that 59 hours is the amount of time that drill has been running. Okay? Lastly, at this rate, how many hours will it take until the drill reaches negative 250 feet? Again, it's just another entry in our table here. We're told negative 250 feet. We need to get to hours, so we need to divide by that constant of proportionality. And hopefully you notice these two numbers have a lot of similarities, just different place values. And this is just going to be a multiple of 10. It's actually going to be 100 hours that drill would be running for negative 250 feet. And if we look at our graph, we didn't quite extend our line long enough here. But if we look at negative 250 feet, where it hits the line is, well, on our line, it's 90 hours. If we drew it straighter and more accurate, I think it would have been much closer to 100 hours like it should have been. Okay? Lastly, we've got just a little bit of matching to do. We have 4 very similar division expressions here. We've got 15 and 12, 12 and negative 15. So we're changing the signs, we're changing positives and negatives here, and we're just matching this up. This is something that shouldn't require a calculator, okay? And I think if I rewrite these expressions to look more like a fraction, that might help a little bit. And we've got 12 divided by negative 15, 12 divided by 15, and 15 divided by negative 12. Okay, now let's look at the positive examples here. So we have 12 divided by 15, 12 fifteenths or 15 twelfths. Now these are reciprocals of one another. One of these has a value less than 1 and one has a value that's greater than 1. And if we look at our decimal values, it's pretty clear which one has a value greater than 1 and which has a value less than 1. That's a match we can make right now. So 12 fifteenths is less than 15 fifteenths, which would be 1 whole. This is the value less than 1. It's definitely going to give us a positive quotient when we divide two positive numbers. So B would be the best match for that. Now, if we look at the reciprocal, 15 divided by 12, 15 twelfths, this is greater than a whole number. And then this answer here would be greater than a whole number, D. So D would represent that one over there. We got D and B. Now all we have to do is realize that with one of these numbers being negative, it's just going to turn that quantity negative, but we're still doing 12 divided by 15. It's just negative 15 now. So if this is 0.8, 8 tenths, then this is going to be negative 8 tenths. And we'd have A, and the same would kind of follow with this other one, C. So please work on your practice problems. Ask me any questions or help on Zoom, and I will be glad to answer them. And I hope you have a wonderful day.